Okay, let's look at the case where the function given is actually a velocity function, right? So this is a velocity function. Then we want to try to find the area, say, under the velocity function from, say, t equals a to t equals b, right? So we're going to use the same approximation technique, right sum, and to write the maybe R5 or something like that. All right, so I'm going to split that into 1, 2, 3, 4, 5. So you have, so this is going to be our t0 since variable is t. So this is going to be t1, t2, and t3, and t4. And the last one is t5, which is b. All right. So we can find that delta t. So the the length of the subinterval. Let's find the delta t. All right. So delta t is going to be simply so the length of the interval is b minus a. Then you divide by 5, right? So that's delta t. All right. Then if you want to find the right sum, so say R5, so this is going to be, all right, so I'm going to use the right endpoint. So I'm going to use the right endpoint and draw a rectangle here, all right. Shoot. All right, I keep on doing this. So draw a rectangle here. All right, use the right endpoint, draw a rectangle here. I use the right endpoint and draw a rectangle here. Use the right endpoint and draw a rectangle here. And the last one. All right. So you can see that the first one, the height is determined by v of t1. Second one is v of t2. And the third one is v of t3. And fourth one is v of t4. And the last one is v of t5. Then multiply by the width is delta t, right? And if you remember from maybe middle school, right? If you multiply velocity and time, so you can see that if you multiply, so this is a velocity and time together, right? So you multiply those two guys together. Right, the velocity times time gives you distance, right? So which means that this tells you or approximates the distance traveled over that time interval from t0 to t1. And the second one is that v of t2, same way, times delta t is going to be the distance traveled over the second time period, right? And so on, and you keep on adding them. So this is going to be the distance traveled approximation for the distance traveled over the time from t equals a to t equals b, right? So if you want the area under the curve, which is we can do the limit of Rn as n approaches infinity, right? Right? But this area represents the distance traveled by whatever that's moving with the given velocity, right? So area represents, if you have a function which is a velocity function, then area under the velocity function is going to represent the distance traveled over that time period, all right? That's it. I hope that this was clear.